Okay, if we want to figure out the relationship between these two, you might be tempted just to start and look at your chiral center, okay, which actually doesn't change. In both cases, that chiral center is S configuration. But the more important thing here to look at is the double bond. In the first one, the two groups on the double bond, the two non-hydrogen groups, are on the same side, which makes this a cis double bond. On the second one, the two groups are on opposite sides, making this a trans double bond. The fact that you have a cis and trans double bond, first of all, just remember that you cannot rotate around double bonds. Double bonds locks these groups in place as cis or trans. So having that double bond makes these two things non-superimposable, and they're not mirror images. Therefore, these two represent diastereomers. Okay, just to give you a couple of other examples that might follow along with these. Let's say you start with the original cis compound. Okay, if the double bond stays the same, but just that chiral center is inverted, okay, now we have a pair of non-superimposable mirror images. Okay, if you have trouble seeing the mirror image, just flip this one on the right over 180 degrees. And of course, a 180 degree flip will put that bromine from back to out. And now, if you compare this one and this one, you should be able to see the mirror plane of symmetry between the two. So these two would represent enantiomers. Okay, now if you had one where let's say both the double bond and the chiral center are switched. Okay, your chiral center is switched. A common misconception is for people to think, well, both of those stereocenters are swapped, so they must be enantiomers. Double bonds are a little different here because even though the double bond configuration has changed as well as the chiral center, think about the definition. These two things, they're non-superimposable because the cis double bond won't superimpose on the trans double bond. And the chiral center is inverted, which doesn't really have much of an effect here. So the cis and trans double bond immediately just makes this a pair of diastereomers.